Alright, so here we have a circle with the radius drawn, and then a point outside the circle, and then from A to B is a tangent line, and then from A to C is just a line segment. Now, anytime you have a circle with a tangent line, let's say I hit the circle at one point, alright, it's always going to form a right angle with the radius at that point of tangency. Alright, so we have a little right angle here, and that's already given to us. So we're trying to find r, the radius of the circle, and really we don't even need to think of this in the context of a circle. We could just use this right triangle here and look at, like, okay, BC is A, 14 is B, and 7 plus r is C, and that's a right triangle, so we can use the Pythagorean theorem. Yeah, we don't know two sides, but it's only one variable we don't know, so we could still, like, just plug it into the Pythagorean theorem. So you get, like, r squared plus 14 squared is equal to r plus 7 all squared. Alright, so we gotta make sure we FOIL this. So we get r squared plus, I think this is 196 squared, I'll double check that. Now what I mean by foiling this, we don't want to write it as r plus 49, because r plus 7 squared is really r plus 7 times r plus 7. So when you FOIL it, you get r squared plus 7r plus 7r plus 49. And now we have a quadratic, but we could get rid of the r squareds by just subtracting it on both sides, and then bring this 49 over to this side. Alright, so then we do 196 minus 49, which is 150, sorry about that, 147 is equal to 14r. So that disappeared, that got brought over, both these got brought over to the other side. That's your 14r, and then divide by 14, and we get the decimal, 10.5. So we get the radius is 10.5, and that's what we were looking for.